How you doing? Hello, hello. All right, good morning. I'm hoping that everybody's doing well. All right. This is Mr. Woodford. I'm so very excited to continue working with you guys. I'm hoping everybody's staying healthy and safe. I have been grading assignments. I have been very impressed with what I've been receiving. I would encourage everyone to keep working, keep trying. If you know somebody in your class who may be bored, just reach out to them, say hi to them. I'm going to be reaching out to students just to touch base with you all. And regarding what you've been doing as well as just seeing how you're doing, and also your academics, as I mentioned. Um, let's dive into the next unit. So we're going to be talking about box plots and outliers. So we've talked about last time, Math 7. We talked about we're in comparing data, right? We're talking about statistics. We talked about creating dot plots and identifying outliers in dot plots. Obviously, mean, range, mode, all the wonderful central tendency data, as well as the 5-point summary, which I've never said that specifically, but the way we create the box plots, which is minimum, maximum, quartile 1, quartile 3, and the median, right? Those are called the 5-point summary or 5 data summary, something like that. What I want to do today is talk about outliers and how to really identify them. Now, when we did last time on dot plots, we estimated them, really looking at the actual picture and saying, based on the picture, what could be an outlier? What could be outside of the general data? However, our observation may not always be accurate, right? We observe them in dot plots, but I want to work on calculating it to make sure we fully understand how to identify an outlier in a given set of data. So let's look at the worksheet together. We're looking at 9.4, right? This worksheet is going to help us to be able to recognize box plots and outliers. Of course, I'm going to refresh our knowledge of creating box plots, talking about percentages of box plots. That way we can help really solidify this data as we go to almost end this unit. So in this unit, we're talking about outliers and box plots now. We're going to talk about 2 more things before we end this unit, which is mean and mean absolute deviation. And those are the last 2 things we should be talking about. So this unit is almost done as well. All right, so let's look at it. So the bell work starts off by giving you this box and whisker plot. It says the box plot below shows the distribution of test scores in Mr. Woodford's Math 7 class, right? As you can see, we have a spring of data from 65 to 100. There's 3 questions here that I want you to answer. What is the median of this box plot? What percentage of students score between 90 and 100? And what percentage of students score between 70 and 90? Let me ask you these questions again, right? What is the median? Looking at this box plot, what's the median? What percentage? So what percentage of this data is between 90 and 100? What percentage of this data is between 70 and 90? Take a second, pause the video, see if you can answer those on your own for now. And then what I'll do is I'll come back and I will walk you through how to do it. So take a second, pause the video. All right, so I'm hoping that when you pause the video, you took a second to reflect and think of what the answers might be. Give me 1 second. All right, great. So let's go over it. So when we look at this particular box plot, the median should be pretty simple or pretty easy for us to be able to look at and quickly identify, right? We should be able to look at the line that's directly in the middle here and say this line in the middle is my indication of what the median is, right? So this line, this would be our median. Okay, so this line here is our median. So we would say the median of this box plot is 80, right? The median of the box plot is 80. All right, cool. What about the percentage? And this is a question that I see a couple students are a little confused on. They have been asking me about help on it. And then the last video, I tried to re-explain it to really give you a better understanding. Every part of this data is broken up into percentages. So for example, if I were to separate this data into 4 parts, you would see one part is here. Sorry. One part is here, right? That's one part. Okay. Another part is here, right? So 1, 2, 3, and finally the last part is here, right? So these are my 4 components to this box plot. It's asking you what percentage of the students score between 90 and 100. So when I look at those numbers, 90 and 100, right? I'm gonna use a different color just to highlight what I wanna make sure I say. 90 is here. They're asking you about the percentage of students from here to, sorry, starting to do a little of a glitch here, so not sure why, but it is. Okay. Yeah, I can see it's not moving as fluent as it was at one point yesterday. Maybe I got too many things open. From here to here. So what percentage of the data is this? If each one is a quarter, right? Each one is a quarter of the data. What percentage of the data is this piece here? What percentage is this piece? What we can assume is that since this piece is the last of the 4 quarters, right? This is 25% of the data, the higher 25%, but nonetheless, it is still 25% of the students. I'll write it in yellow, it's all right. All right, 25% of the data, okay? And lastly, if we look at 70 to 90, this is this middle, but it takes up 2 sections in the middle. What percent is that? That's going to be 50%. 50% of the students scored between these 2 grades, okay? Awesome. Take a second. Make sure you can understand that, right? And we'll continue together in 1 minute. All right, great. So I'm going to clear the text. Once again, remember in a box plot, each portion is separated into 25%. And that's really what they're asking you. If you look at the data they're talking about, whether it's 9 to 100, what percent of that data? That's 25%. 70 to 90, you can see it's that middle, which is 50% of the data. And that's how we got these answers here, okay? I'm going to clear the text and we're going to continue. All right. So the question that I want you to think about is how do we identify outliers on a box plot? They're not the same as when we identify them on a dot plot, and we're going to talk about that in a second. And then we're obviously talking about statistics and outliers and observation that is numerically distant from the rest of the data. Before we dive into me modeling it for you, and there's a good amount of things we're going to do, take a second once again to see if you can identify from these box plots what the outlier is, right? It shouldn't be too complicated. I think we all should be able to quickly identify them. But looking at these dot plots, what is the outlier? Okay. Pause it if you need to. If you was looking at the first one, an independent practice, letter A, you will be able to identify the outlier here is 19, right? The outlier here is 19. Okay. Okay. Make sure you pay attention to the actual numbers here and how they're going. This is going by 2s in some sense, but actually all the middle lines are 1s. So 18, 19, 20. Okay. That's important even when you set up your own number line to make sure you pay attention to what the actual numbers are distributed as. Okay. Look at the second one here. What is the outlier from this dot plot? And we should all agree that the outlier here by observation is 10. Okay, now this is observation. This is not factual, right? This is not like we've calculated the outlier. This is by looking at it and observing, saying, okay, based on observation, it looks like the outlier is 19. It looks like the outlier is 10. Now, I want to tell you something that's very, very important. And these situations here, even though the outliers are seen by us visually, there are situations that may look like this, but the extra dot that's out there, that 10 or that 19, may not be the outlier, right? May not be the outlier. And these particular situations, they absolutely look like the outlier. No doubt in my mind, right? No doubt in my mind. However, there are situations we're going to look at, especially when we get just regular numbers and we create them as box plots that I want us to focus on. Okay, let's dive into what we're doing today in our lesson. That way we can make sure that we all understand it and we get what we came for. Okay, turn with me to the next page, please. Can you give me more shoes? All right, so when we look at the first thing this modeling says, Joe interviewed the cross-country team at his high school to find out how many miles per week they run. The following list is the data Joe collected. So this is the data he collected regarding how many miles per week they ran. So how many miles per week they ran? Somebody ran 15 miles, somebody ran 25 miles, somebody ran 33, somebody ran 47, somebody ran 52, and so on and so forth, right? The first thing we need to do with any type of data that we're given, even if it was a dot plot, first thing we need to do is reorganize this data from least to greatest, from smallest to largest, right? That'll help us to really get a better understanding of what was the lowest number somebody ran, what was the highest number someone ran. So take a second, right? And matter of fact, if you want to take a second and pause it to organize it, you can. I'm going to do it right now. That way we can all see it together as I walk through it myself, okay? He took something. I'm not sure what he took.
Nice, come here. Nice.
Can you go to him, babe? That way. All right. So if I were to rewrite these numbers, right, from least to greatest, what I end up getting is this. I end up getting 8. 15. 25. 29. 33, and I'm just looking at my notes here that I have on the side. That way I make sure I write it correctly. And this thing is glitching a little bit. 35. 37. Now, if you are submitting assignments online via editing the actual PDF, I'm very proud of you. I'm very proud that you're actually being able to do that. What I would also suggest is that you what I also suggest is that you would sorry, this thing is moving slow. Is you can also use the actual text box here to actually put your actual notes in. So I could have done the text box here. It would have been a lot quicker than me doing it using the pen. But I would definitely recommend it. One other thing I need you to do, and this is a definite, I should have done this right away when I started, is count how many data points you have here. Because if you started going back and forth to write down the numbers and then you end up going to calculate and you don't get the right stuff, it's most likely probably because you didn't check to see how many data values you actually had. And if you don't check your data values, you may not end up getting the right stuff. Okay, so 54, 55, and then 56. Okay. All right. So if I count these, I just want to make sure I count them. There should be a total of 18 numbers here, right? You count them, make sure there's 18 numbers here, 18 data values. If we count ours as well, you'll see that there's 18, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 values here, 18 values up there. After you write them from smallest to largest, now we have to identify what's the minimum, what's quartile 1, median, quartile 3, and max. And if you've been doing the work up until this point, that shouldn't be too complicated for you. You should have an understanding like, okay, I remember what the quartiles are. But I'm going to refresh you to make sure we're all on the same page. The minimum value here is the smallest number in our data. The smallest number in our data is 8. Now, I want you to pay attention to this because sometimes our smallest or highest number in our data may end up becoming an outlier, right? And if it becomes an outlier, then we're going to have to recreate our box plot later on. But for now, the minimum is 8. The maximum, we can all see that's 56. Okay, and now we got to figure out quartile 1 and quartile 3. And well, the median we can also figure out as well right now. So the median, if you need to know, it's we can literally cross out one number on each side in order to find the median. This is one way of doing it, right? You cross out one number on each side to get to the middle. Remember, median means middle, okay? If you know that there's a total of 18, what you can end up doing is you can say, okay, since there's 18, let me just go to 9 on both sides. That would help me get in the middle. But if you wanted to do it this way as well, that's perfectly fine. Just get to the middle number. And in this case, you'll see we have two numbers in the middle. So what do we do when we have two numbers in the middle? What we end up doing when we have two numbers in the middle is we add them together, and then we do 41 plus 42.
Where's your cup, Shasta?
And we divide that by 2. Right there. That was just right there.
That's not nice. Oh, thank you.
41 plus 42 divided by 2. Okay, so we add these two numbers in the middle and we divide them by 2. Now, what do we get when we do this? We end up getting 41.5, right? So our actual median for this example is going to be 41.5. Let me actually write that in blue so that way all the actual key values here are in blue. Okay. You okay? Okay. Right here. All right, so we're gonna.
Thank you, Daddy.
You're welcome, baby. So our median here is 41.5, all right? Okay, 41.5 is our median. Now, what does that mean? That tells us, and I'm gonna make sure we get this, because this is something I also noticed that we was having a problem with, right? If you identified that the median of the data is right here, right? Let's say the median of the data is here, and that's 41.5. Then I use all of these data to find quartile 1. I use all of those data to find quartile 2. So I start from 41. I say, okay, well, let me cross out to find the median of the lower half of the data. I'm going to go, okay, 41, 8, 15, 40, 37, 25, 35, 29, and you'll see that you have just one number in the middle there, and that number is 33. 33 is your median, is your quartile 1, is the median of the lower half of the data. So this is 33 here. Now, what about the higher half, right? The higher half, once again, we're gonna start from 42. Do not try to say, okay, let me use 41.5 here. No, we gotta say, okay, cross out 42, cross out 56. 55, 45, 45, 54, and we just go one by one. I know we kind of already crossed out some stuff, but if you need to, this is where, even if you didn't want to cross them out the way we did before, if you want to use a little dash or something else to indicate your way to get to the middle, that's perfectly fine, okay? That way your numbers aren't so confusing when you look at them to see what's in the middle, right? But this is another way to be able to do it. I'm just showing you other ways, okay? So in this particular situation, the median here of the upper half of the data is 48. Okay, 48 is your upper half of the data. I want to check to make sure those are the same that I have. Yes, they are. Perfect. Okay, now we got to make ourselves a box plot. Okay, now I gave you a hint. Every single one of these problems, I give you a hint. And I think this is going to be the longest video just because there's so much for us to do. The hint is to go by 4s. Go by 4s on each one of these numbers. That way you can fully fulfill it. Now I'm going to start actually at 8 because 8's my minimum. So I'm going to start at 8 down here. All right. So I'm going to start at 8. Then I'm going by 4. So that's 12, 16, 20, 24, sorry. No, technical difficulties always mess me up, and I don't even know why. So 24. Okay. 24. 26. Right, and you can always do this if you're making a number line with the actual like text box. Let me show you what that looks like, because that probably would have definitely saved me some time if I would just done it with the text box. Okay. 30, right? 32, No, like not 32. 34, because we're going by fours, right? Yeah, see, I messed up before too. Dang. No, my brain is doing so much here. I got my kids over here distracting me. Okay, so 30, 34, we get 38. Okay. 42. Right, 46. 50. I messed up somewhere. Oh, let me check again. Yeah, I messed up right there. Oh, so I'm sorry. This is not good when I have technical problems and then trying to do it and then all the other distractions. Okay, let's start again. Let's start from here because I realized that I actually messed up at 26. I shouldn't have had 26 there. That's messed up all my numbers. Bear with me, children, as the pad is still moving very delayed, but it's the best way to do it, I realize. So 28, 32, 36, 40, 44. Hurry up. All right, sorry. 44, 48, 52, and then 56. Okay, that's how it should have been. I messed up on a number and it just cost me everything. Cost me a little bit of time, but let's keep going. So we put our numbers in the number line. I am giving you a hint on each one of these worksheets on exactly the actual numbers you can go by. But you can see I have the minimum there, I have the maximum there, so everything else should be in the middle. Now, let's create ourselves a box plot. If you remember how we did it, we need this 5-number summary, right? And we put lines, right? Line at 8, a line at 33. Which is approximately there. A line at 41.5, which is like right here, a line at 48, and then finally a line at 56. Now, the numbers that are in the middle here, right? These numbers here in the middle, we do need to connect them. Okay? Make a box, because the name of this is called a box plot. So we make a box here. Sorry, mine is not too pretty. Okay? And then what we end up doing is we connect the actual whiskers, or just make a line going from the middle all the way out to them, okay? Like that, okay? And you can see here, boom, we have our box plot created for us. Now you can see that it looks a little bit more leaning to the right, which means it's skewed to the left, which is complicated. And I know we talked about that a little bit before, but nonetheless, you can see that it's leaning more to the right side of the data. So what I want to do is this. Let's keep going. Let's answer some questions, and then we're going to go through. So if you need to copy down anything, please copy it down. I'm going to clear it in 3, 2, 1. All right. How many miles do the bottom 75% of data's 75% of runners run per week? So how many miles do the bottom 75%? Right, so we're looking at the bottom 75. So the lowest 75, right? How many miles do they run, right? Right. What's the average in some sense? And when we look at that, based on our data, you would have noticed that the bottom 75% of runners, right? The lower 75 would have been at quartile 3. So what is quartile 3? That's what they're asking you. What is the value at quartile 3? Which in this case is 48. So we would put here 48 miles because that's how much 75% of the data is. So we're talking about 48 miles is what 75% of the runners run per week. What is the IQR of the data? What is the IQR? Now IQR is simply stating what is quartile 3 minus quartile 1, right? So far, everything we've done so far is not brand new. Nothing's brand new so far. The brand new is where it says IQR rule for outlier. outliers, right? You should be able to create a box plot. You should be able to number it. You should be able to identify that 5-number summary. Now, we're talking about what we just did, which is how do you calculate the IQR? We say, okay, 48 minus 33, because I believe 33 was quartile 1. Okay. Right, so this is a 3. Right, so 48 minus 33, what do we get? We end up getting, for this particular situation, what the IQR is 15. This thing is driving me nuts, and I'm not sure why it's doing this. Cool. All right, so it's 15. All right, so our IQR is 15. Now, this is what's very important in this lesson, and if you wanted to, this is where I would recommend you pay attention, right? We need to take the IQR, we're going to multiply that by 1.5. Now, why are we doing that? We're taking it because we want to figure out what's the limits, what numbers are the real max and the real min, and any numbers on the outside of that are the outliers, okay? Because what's the furthest we can have our minimum? What's the furthest we can have our maximum? And that's the way we're going to find that, by using the IQR. So we're going to take the IQR number, which is 15, right? We're going to take 15, and we're going to multiply this 15. Oh, okay, hold on, so sorry. Yeah, I'm just going to use the text for now. All right, we're going to do 15, and we're going to multiply that by 1.5. Okay, we're going to multiply that by 1.5. Now, what do we get when we multiply that by 1.5? We get 22.5. That's what we end up getting. Okay, so our number we're going to need to use is this 22.5. This is our new number. So when I refer to later on as our new number here, right, if you look down here, I can stay black, it's fine, right? When I refer to this new number here, or this right here, right, new number, I'm really referring to this number we just created, okay? Because this is our new number, right? It's our new number that we just created. Okay. All right. So we need to then take this new number and subtract it from quartile 1. And let me show you what that is. All right. So we're all on the same page. So what I'm going to do is say, okay, the new number, subtract it from quartile 1. What is quartile 1? Quartile 1 is 33 minus, right? We got a minus here because we're taking it from 22.5. What do we get? When we subtract that from 33 minus 22.5, we get 10.5. That's the smallest number that our data can go. If our data goes any further than that, if it goes any smaller than that, that means it's an outlier. So for example, if a number was less than 10.5, that means that number would register as an outlier. Right, let's keep going. What about taking quartile 3? Add this number to quartile 3. We said quartile 3 was 48. So we're going to do 48 plus this 22.5, and we're going to end up getting 70.5, right? 70.5, which means that if we have a number that's greater than the 70.5, that number is an outlier, right? That number is further out than our data, so that number would be considered an outlier, all right? So what I want to do now is this. I want to say, okay, well, are there any numbers that are less than 10.5? Is there a number less than 10.5? Okay, so I'm gonna actually write something here that I'm hoping that this thing don't glitch for me for, because I think this is actually really, really cool. And well, not really cool, I think it's really important that you get. All right, so outlier, let me write it here. Right, outlier, right, is less than this 10.5. So if there's a number that's less than 10.5, that's an outlier. Another outlier indicator is if it's an outlier that's greater than . Right, our other outlier will be anything greater than 7.5. So when we think about that, well, do we have any numbers that are less than 10.5 or greater than 70.5? Yes, we do. Right, and this is where I'm getting us to really understand that there is an outlier amongst the data we had before. That outlier would be the number 8, right? If you look back at our data, you'll see that we had an 8 there, and 8 is less than 10.5. Are there any numbers greater than 70.5 in our data? No, there's not. But there is a number, in this case, less than 10.5, which that number is 8, and that is an outlier. So what do we do with this now that we identify an outlier? We have to go back and modify our box plot. If you want to go back on your page above and erase and fix it, that's fine. I wouldn't mind you recreating a new number line as I created for you at the bottom of this page. Okay, what does that mean? That means I would go here and I would write my brand new number line. I'll create all my numbers that I need here. Right. So going from what we did before, we're gonna write 8, right? 12, 16, 20. Yeah, see, oh man, my brain is so messed up right here. It's just trying to do this. I'm gonna fix that. Okay, so those are all there, and I just need to extend it. And once I extend it, it should be A-OK. Okay. All right. So imagine you put your number line like this, right? It's there. Now you go to create your actual box plot, right? And you're saying once again, now you gotta keep in mind, 8 is no longer the minimum because we recognize that 8 is an outlier. So what do we do there? We draw a circle. Draw a circle. Whether it's a closed circle or open circle, it does not matter. Some people do open circles, some people do closed circles. It does not matter. These are not like inequalities here, but you do need to put a dot there or a circle indicating that that's outside the data. So then what does our minimum now become? Because our minimum is going to change. Our minimum now is the new next number that was next to that 8. So whatever the lowest number was that wasn't 8 is now our minimum. So that means it's going to be 15. So 15 would be here. Then we would still have 33. Right? Then we would still have 48, and we would still have our 56, right? So these are our 5-number summary now. I'm missing one. Missing one. Hold on. Oh, our median. I'm so sorry. Median, 41.5 right there. Okay. Okay, and then you recreate your box plot like this, drawing your whiskers out. Okay, and then you'll see you have one outlier that's outside the data. And that right there is how we adjust our actual minimum maximum to create a modified box plot where we identify the actual outlier. This is how we calculate if outliers are actual outliers, right? So on a dot plot, we can't really do that, but on a box plot, we can actually figure out if any of the numbers actually are an outlier. I know this is a lot. I understand that there's a lot here. However, the best part is not a lot of this wasn't new. Only part that is new was these last step 1 to step 5. Everything else you should have been able to grab from other stuff. I just need to make sure I incorporate it here to make sure we understood how we got to this part here at the bottom. All right. Thank you so much. Please complete the rest of this worksheet. I know there's 1 classwork activity and then 2 of these on the homework portion. Please complete all 3. I know it's tough, but the more you practice, the better it will be for you to understand how to actually calculate the outliers from a box plot. All right. Thank you guys so much for watching. I will talk to you later. Please stay safe, stay healthy. Talk to you later. Bye-bye.